Hello, this is section 4.5, the fundamental theorem of algebra. So, fundamental theorem of algebra, a polynomial f of x of the degree of n, and the degree is greater or equal to 1, has at least one complex zero. The fundamental theorem of the algebra guarantees that every polynomial has a complex factorization if we are allowed to use complex numbers. Number of the zero theorem. So, number of the zero is going to be the at most n distinct zeros, okay, which is when the degree is n. So number one, use the figures to determine the graphically number of the real zero and the number of the imaginary zeros. So all zeros for the given polynomials are distinct. So the zero for the first one is this is only the zeros because that's x intercept. So I want to say the real zero, there's a one real zero, and then when I check the degree is going to be the third power, so that means we have to have a 3 zeros. So since the 1 is a real zero, that means the 1 subtract from the 3, which is a 2, so 2 will be there are 2 complex zeros, which means imaginary zeros, so it's not the real zero. Okay, for the second one, the graph is not touching any of the x-axis, so there's no real zero. But this polynomial is a degree of 4, which means there'll be a 4 complex zeros, which means imaginary zeros. Okay, so now we can talk about the conjugates. So conjugate zero theorem. So if the polynomial f of x has only coefficients, if a plus bi is going to be the one of the zero, which means a minus bi is also another zero. So when you have a complex zero, it's always come with the two sets. So polynomial equation with a complex solution. So every polynomial equation of the degree of n and can be written as a sub n x of n plus all the way to x sub 0 equal to 0. And then if we let f of x equal to the as a functions, and then factorization form is this one. And that means there are solution of the polynomial equation has a 0 of the c1, c2 all the way to cn. Okay, the number 2. Find the polynomial f of x is a degree of 3 with the leading coefficient is negative 3 and 0 is 4, 2i, and negative 2i in. So complete factor form, which means f of x, and which is a sub n of, there's a 3 0, right? So 1, 2, 3. So it would be a x minus c1 as a first zero, c2 as a second zero, and c3 as a third zero. But leading coefficient is, which is a sub n, is negative 3, and the x minus 4, x minus 2i, and x minus of minus 2i become 2i. Okay, so that's actually the factor form. And the expanded form means we're going to multiply them out, okay? So which means this is what I multiply, so minus 4. And here, I'm going to multiply these two, actually the product of the sum and together. So in order to multiply, you're going to multiply x to x and only this to this, because the other two terms in the middle will be cancel each other. So you will get as x squared minus 4i squared, which is the same as negative 3 times x minus 4, same as x squared minus, which is negative, I squared is negative 1, so plus 4. And then if you FOIL this binomial to this binomial, and then you multiply x to x squared x cubed, and then multiply negative 4x squared, and then multiply x to the 4 plus 4x, and multiply 4 times negative 4 is negative 16. And then you multiply negative 3, distribute it, okay? And then you get negative 3x cubed plus 12x squared, and minus 12x and plus 48. So that's the expanded form. Determine the complete factor form for the f of x equal to x cubed minus x squared plus 9x minus 9. So this one, actually, you can use a factor by grouping. And then the GCF of each group, so x squared minus x minus 1, 9 times x minus 1, factor it out, x minus 1. And then you got x squared plus 9. But x squared plus 9 is not used to be the factorable. But if you think about the imaginary, this becomes x squared plus 3i. And oh, not the square, sorry. It's going to be x plus 3i. And then becomes x minus 3i. And then when you multiply them out, you'll get the x squared plus 9. Number 4. Find a cubic polynomial f of x with the real coefficients and leading coefficients negative 2 and the 0, 1, and 2i. Express of the f in that's next page in the complete factor form. So the leading coefficient is negative 2, and then zeros are 1, 2i, but which means negative 2i is also the another 0 too. Okay, because the complex zeros always come with it as a set. All right, so with the factor form, f of x equal to a sub n, x minus c1 as a first 0, c2 as a second 0, and c3 as a third 0. So a sub n is negative 2, and the x minus 1, x minus 2i, and the x plus 2i. And then if you, that's all. That's a factor form. And then if you want to get an expanded form, now we're going to keep multiplying. So negative 2 of x minus 1, and then if you multiply x minus 2i times x plus 2i, you'll get the x squared plus 4. And then if you FOIL x cubed minus x squared plus 4x minus 4 and multiply negative 2, negative 2x cubed plus 2x squared minus 8x plus 8. Okay, so that's expanded form. And then number 5, find all 0. F of x is x to 4 plus 2x cubed plus 4x squared plus 2x plus 3, given that the 1, 0 is I. Okay, so which means if there's a 0 is an I, and that means a negative I is also 0 too. So you can make that as a linear form as x minus I and x plus I. And then you can multiply this as x squared plus 1. And then you can use a long division to divide it. But I like to use the synthetic division, okay? So pull out all the coefficient. And then I divide by 0, which is I. So drop the 1, I, 2 plus I, multiply by I to the 2 plus I. So it is to be 2i plus I squared is a negative 1. So you got 3 plus 2i. And then multiply by I, you got the negative 2 plus 3i. And then you got 3i. And then multiply become negative 3 is a 0, see? And then I want to use a negative I to multiply. So I drop negative I, which is a 2. Negative 2i, I got 3, and then negative 3i, which is becomes 0. So we have 2, 0, but they're asking for the find all zeros, right? So now this was x to 4, now x cubed, and then it's going to be x squared. So you're getting the x squared plus 2x plus 3 equal to 0. And this is not factorable, so we have to put the quadratic formula, which is negative b plus minus b squared minus 4ac over 2a, which is negative 2 plus minus 2 squared minus 4 times 1 times 3 over 2 times 1. And then negative 2 plus minus 4 minus 12, which is negative 8 over 2, which is negative 2 plus minus is going to be 2i red 2 over 2, and cancel 2's. You got negative 1 plus minus I red 2. So there'll be 2 other zeros, which is a complex zero. All right, so those are the zeros. Okay, so and then example 6, which is, I think I should this one problem on the next page. Okay, so example 6, I have x cubed equal to 2x squared and minus 5x plus 10. So if I subtract the 2x squared both sides. Add 5x both sides. Subtract 10x both sides. And then I got x cubed minus 2x squared plus 5x minus 10 equal to 0. But we are solving this equation, so I want to do the vector by grouping. So vector by grouping, x squared comes out as x minus 2. If I pull it out as x minus 2, which is x minus 2 times x squared plus 5. And then you get the x minus 2 equal to 0. X squared plus 5 equal to 0. So first solution is a 2. And then subtract 5 both sides. X squared equal to negative 5. Square root both sides with a plus minus. X equal to plus minus I radical 5. So you got another 2 solution from here, which is matched to the third power. Now for the next one, I want to adding the x squared both sides. I got x to 4 plus x cubed plus x squared equal to 0. Plus 1. So first solution is going to be x squared equal to 0 and x squared plus x plus 1 equal to 0. So x equal to 0. So you got a one solution, but that repeated twice. And then quadratic formula, negative b square root of plus minus square root of b squared minus 4 times a times c over 2 times a. Negative 1 plus minus 1 minus 4 over 2. Negative 1 plus minus square root of negative 3 over 2. Negative 1 plus minus I read 3 over 2, which is not reducible. So you can write this, or you can just split that as a fractions. Okay, so write 3 over 2i. Okay, so either one is fine. All right, so you got the actually totally 3 number of the solution, but one solution is repeated. This is repeated. Okay, all right. So that's for the finding of solutions for 4.5. Thank you for listening.